Okay, so here we have a set of data on family size for a randomly selected group of people. Our idea is to try to summarize this data. I've already listed them in order, so let's do what we call the 5-number summary first, because that's always a good one to do. So let's go over our minimum value, which is 2, and our maximum value, which is 5. Now, in between, we have the first quartile, the median, and the third quartile. The median is the middle number. So here I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 datas. So the middle number will be the 5th value. And the 5th value here, of course, is 4. That's our middle number because there's 4 on either side. So that will be our median. Median is 4. The first quartile is the median of the lower half, but because with an odd number of data, we are not going to use that middle number. So we use these 4 down here. The middle occurs between 3 and 4. We've got an even number of data. So my first quartile will be 3.5. Same thing with the upper half. The median of the upper half, 4.5. Q3, Q1, that's 4.5. These values are what we call, in statistics, the 5-number summary. Remember, to get a median with an odd number of data, you simply use the middle number. For an even number of data, you take the average of the middle 2 numbers. Got it. Okay, let's talk about mean. You guys know what this is. You've been doing it your whole lives. The symbol we use in stats is X bar. Okay, that's a mean. That's simply the sum here divided by the total. I'll just do this in my P range. 5, 9, 13, 17, 21, 25, 35 divided by 9, which is 3 8/9. And I know my ninths and decimals. That's 3.8 repeating. Okay, very nice. That's the mean. How about the standard deviation? Okay. The standard deviation is a measure of distance from the mean. You can think of it as it's basically the average distance from the mean. And it's an important calculation. For example, in Mr. Doucette's geometry class, he might have an average of 85 with a standard deviation of 2. Right? That means everybody's kind of clustered around that 85. Whereas Mr. Ulrich might have an average of 85, but a standard deviation of 10, which means he's got some 75s and 95s, whereas the Deuce has like 83s and 87s. Follow me there? Standard, that's what standard deviation measures. How do we calculate it? It's a little complicated. Fortunately, when you take a statistics and probability class, you'll have to do this by hand, but fortunately you're not in a statistics and probability class now. We're mostly going to use our calculator, but I'm going to go ahead and show you the formula. It's the sum, it's the square root of the sum of all the differences from the mean squared divided by the number of data points. The variance is the square of the standard deviation, and the standard deviation is just this. So, do you need to know that? Not really. I'm not going to have you calculate it by hand, but I want you to get an idea. So I take 2 minus 3.8 repeating, square it. 3 minus 3.8 repeating, square it. 4 minus 3.8 repeating, square it. Divide by 9, take the square root of that answer. And that will give me the average deviation from the mean. We're going to talk about standard deviation in the next video when we talk about the normal curves. Okay, so these are my values. And this is how I calculate some of these statistics. And they can help us sometimes describe the data. Okay, great. Next, we'll look at some videos of some pictures of how to graph this data.